All right, so here's our steps. Remember, when we're solving any word problems, read the question. That's good to start. Figure out what variables we need to solve for, and make sure you label what the variables are. Don't just start writing your equations, okay? And then write your system of equations using those variables and solve your system. Figure out what your solution is and verify if it is reasonable, okay? When we're solving like an application problem like this, yes, when we're solving systems, we usually write our answer in parentheses. Is it going to make sense to write our answer in parentheses for these type of problems when it's a word problem? No, we're going to answer the question as what it's being asked, okay? So if I read this, it says, let's see, landmark Title IX legislation prohibits gender discrimination in sports programs. In a recent year, the national average spent on 2 varsity athletes, one female, one male, was $6,050 for Division 1A schools. However, average expenditures for a male athlete exceeded those for a female athlete by $3,900. Determine how much was spent per varsity athlete for each gender. So what we need to do is go back and figure out what is our variable. What are we being asked to solve for? At the very end, it usually tells us, what are we solving for? How much money per varsity athlete, right? So we can say let X equal, that's a little large for my font size. Let's say X equals money spent on female athletes, and Y can equal money spent on male athletes. If you want to choose other variables other than X and Y, you can, but I'm just going to choose X and Y to keep it easy. Okay, so I need at least 2 equations here. If I go back and look, it says average spent on 2 varsity athletes is $6,050. So what is average? How do I find the average of things? Add them together, divide by however many there are, right? Yeah. So I'm going to take both male and female and add them together, but divide by the number, so divide by 2, and that's going to equal our $6,050. Okay. The second sentence here says average expenditures for male athlete exceeded those of a female athlete by $3,900. So our male athlete is getting $3,900 more than a female athlete. How am I going to write that equation? Yeah, X plus 3,900, right, is equal to Y. Okay, now I just got to solve the system of equations. Is this going to be easier to do substitution or elimination? Probably substitution there, right? So I'm going to plug in that X plus 3,900 for Y. And don't forget that divide by 2 piece. Okay, how do I undo divided by 2? Multiply it. And when I multiply by 2, we end up with 2x plus 3,900 is equal to 12,100. Nice little 2-step equation here. I subtract 3,900 over, and I get 8,200. And divide by 2, we get 4,100. Okay, and then my Y value, I'm plugging in 4,100 plus 3,900 to give me a total of 8,000. So I want to make sure I'm answering this question here. This question asked us how much does each athlete make. So we would say 4,100 is, or we could just say 4,100 per female athlete. Oh, can't write. And 8,000 per male athlete. All right, so we have to remember a few things when we are graphing inequalities, okay? If I have a less than or a greater than symbol, what kind of line am I going to use? Dashed, yes. Dashed line. If I have a less than equal to, greater than or equal to, then I will use a solid line, okay? Now, how do I know which side I'm going to shade on? Test a point. We got to test a point, plug in, and see which side am I going to shade on, okay? So these first three are just basic inequalities. That's not a system, okay? The last two that we'll do are systems of inequalities, okay? So x is greater than 2. So think about graphing the line x equals 2. Is that going to be a vertical or a horizontal line? X equals 2. Vertical line, okay? So at 2, I'm going to have a dashed or a solid line based on this symbol. Dashed line. So going through the x-axis at 2, and then it is greater than 2. I'm going to test a point just to check. So if I test the point 0, 0, if I plug in 0, is 0 greater than 2? Nope. That is not true, so I'm not going to shade on the side with 0, 0. I'm going to shade on the other side. So everything to the right of x equals 2 is part of my solution. Next one here is y is less than 4. So if I have y equals 4, what does that line look like? Horizontal. At 4, we will have a horizontal line. And it is dashed because our symbol is less than, not less than or equal to. Okay, I always choose the point 0, 0 as long as it's not actually on our line, just easiest to plug in. So if I plug in the point 0, 0, is 0 less than 4? Yes, it is. So that means I can shade where 0, 0 is. So I'm going to shade below the graph. Because it's y equals.
Oh.
Just nice little coloring here. Okay. All right. Also, when you are shading, it doesn't have to be perfect, as long as I can tell where the shaded region is, okay? All right, letter C, there is actually two ways that we could graph this. We could either graph this by getting it equal to y and graphing in the line, okay? Or do you guys remember standard form graphing x-intercepts and y-intercepts?
Nope.
Nope? Okay. I'm going to remind us because it's going to be helpful when we talk about linear programming. All right, so it's going to help us with linear programming, graphing by x-intercepts and y-intercepts. So, good back there? Okay, if I have an equation with x and y on the left-hand side, and I wanted to solve for the x-intercept, that means I'm going to plug in 0 for what? For y. If I plug in 0 for y, 2 times 0 is 0, so then I have x equals 6. So your x-intercept is just x equals 6, or actually the point 6 comma 0. Okay, now if I did instead, I want to find the y-intercept. All right, our y-intercept, if I plug in 0 for x, I have 2y equals 6, so y is going to be 3. So I've got 0, comma 3. Okay, so I can plot these points on the graph, 0, comma 3, and 6, comma 0. Now I'm going to change this here.
Oh yeah, then you just make a line.
Yeah. I made that, now it's less than or equal to, because I want one of them to be solid. So this one will be a solid line here. All right, then I can go ahead and do my best to draw a straight line and explain everything because it's the worst, but that was okay. Not terrible. There we go. Okay, then I am going to test a point. I'm going to plug a point in. I'm going to test 0, 0 again. If I plug in 0 plus 2 times 0 is 0, is that less than or equal to 6? Yes. So I am going to shade everything below this graph is part of my solution. So everything down here. Amazing. You can also obviously graph this just by getting it in slope-intercept form, okay? Solving for y, that works as well. But using your x-intercepts and y-intercepts is going to be super helpful when we're doing linear programming next class. All right, moving on to our system of inequalities. System of inequalities, I'm going to graph both of these things. I'm going to shade where both of these things intersect, or sorry, I'm going to shade both of these things individually, and then I'm going to see where they intersect for our solution, okay? So for this first one here, I'm going to get this to solve for y first so that I can graph it. What was that? I'm going to move that 6 over, so I've got x minus 6 is greater than negative 2y. When I get rid of the negative 2, what am I going to have to do with this symbol? Flip it. I got to flip the sign.
Is it when we multiply 2 or just...
Yes, multiply or divide by a negative. You have to flip the sign. Okay? And then I'm going to rewrite this in terms of a slope and a y-intercept, so it's easier to graph here. So this would be the same as negative 1/2 x plus 3, right?
Yes.
Okay, let's graph this here first. So let's go ahead and graph this here quick. So I'm going to start at 3, and I'm going up 1, left 2, negative slope. As long as you have at least 2 or 3 points on your graph, that is good enough. And then our symbol tells us if it's dashed or solid on this one. Is it dashed or solid? It is dashed. And then when I test my point, I'm going to plug it back into the original inequality. So if I plug in 0, 0 again, I have 0 is greater than 6 minus 0. Is 0 greater than 6? Nope, so I am not going to shade on the side where 0, 0 is. I am going to shade on the other side. So everything above that line is part of my solution. Well, we still have to do the other equation, yes. Yes. We got to figure out where it overlaps, okay? Now this next one, unfortunately, is not a linear term. It's a quadratic. So if I solve this for y, divide by 2 on both sides. I get y is greater than x squared divided by 2. I know it's going to be a quadratic, which is a parabola, but I don't know what my points are going to be. So I need to go ahead and pick a few points. So let's pick just like negative 1, 0, 1, and 2. I would not flip the sign because I didn't divide by a negative. All right, if I plug in negative 1 squared would be 1 divided by 2 is 1/2 or 0.5. Now that's the same thing for 1, right? Because a parabola is symmetric. So that means it's going to be the same value. If I plug in 0, 0 divided by 2, that's 0. And if I plug in 2 squared, 4 divided by 2 is 2. Which is actually the same as negative 2 as well, right? So let's plot all of those points on my graph here. And then if it is less than, that means it's going to be a dashed line. So it's a dashed parabola. And now can I test the point 0, 0 in this case? I cannot. So let's pick another point. Let's pick like, I don't know, 0, 1. If I pick the point 0, 1, I get 0 on the left side, and I would get 2 times 1 on the right side. So is 0 less than 2? Yes. So 0 is less than 2. So that means I'm either going to shade inside my parabola or I'm going to shade outside of my parabola. Those are the two options that you have. So I'm going to shade inside in this case. So everything on the inside of my graph here is the solution for x squared less than 2y. So then our answer is where they overlap, okay? So the overlap part is up here with that boundary line there and that kind of boundary line, okay? So next class, we're going to talk about linear programming. Linear programming is going to talk about what maximizes or minimizes our profit. And so you're going to look at certain points, certain boundary points, which you guys have done before, and we're going to test those boundary points to see what the best, like, value is. Like, if you're trying to sell certain things and trying to get a certain profit, we're going to look at those kind of things next class, okay? All right, last example before you guys have work time and then take your little mini quiz. I've got 3 inequalities here, okay? And we should kind of know the general shape of all 3 of these. Let's talk about them real quick. This y is equal to 2 to the x power. We talked about last unit. That looks like that little exponential there. X squared plus y squared is equal to 9. What does that look like?
Is it a circle?
It is a circle. And then the last one there would be what? Just a line. So let's start with 2 to the x power. If I graph 2 to the x, I'm going to do these all in different colors here. So I'm going to do 2 to the x in blue. So I'd choose a few x's and y's. Let's just choose 3. I think that's enough points to identify what's happening because we know what the exponential graph looks like. If I plug in -1, 2 to the negative first power would be 1/2 or 0.5. 2 to the 0 would be 1. And 2 to the first power would be 2. Okay, so let's go graph that one first. So -1.5, 0, 1, 1, 2. Now, this cannot cross where? The x-axis, right? Yes. Okay, oops, and I accidentally did it correctly, but it was a solid line, right? Okay. All right, next one is our circle. Okay, our circle, the general form is x minus h squared plus y minus k squared is equal to r squared. That's your general form of a circle, where h comma k is your vertex, or actually not your vertex, it's your center, and r is your radius. Yes, so I have to take the square root of 9. So my radius would be 3. My center would be at what? 0, 0. So a pretty straightforward circle there. It starts at 0, 0 with a radius of 3. So 0, 0. I'm going to go out 3 all the way around. And that kind of looks like a square, obviously, but I'm going to do my best to make it a circle. Is it a solid line or an open or a dashed line circle? Solid line circle. That wasn't bad. Not great. Okay, I heard someone say shading, and I totally forgot how to. I forgot to shade the first one. So let's go back and shade the blue one. If I shade the blue one here and test 0, 0 is 0 greater than or equal to 1, because 2 to the 0 is 1, right? Is 0 greater than or equal to 1? No. So I'm not going to shade to the top of that graph, because I can either shade this way or I can shade below. So I'm going to shade where 0, 0 is not, okay? 0, 0 is not true, right? So I'm going to shade on the other side. I'm shading up here. Because 0, 0 was false. Oh, wait. No, wait. 0, 0 was not true, right? Yeah. So I want to shade on the side that is true. Yeah. So I want to shade on this side. Yeah. All right, if I look at my circle, my circle, if I plug in, can I test the point 0, 0 for my circle?
No.
Why not?
Because it's in.
Center?
It's in the circle or outside the circle is how we're shading it. Either inside or outside.
Okay.
So I can test 0, 0. If I plug in 0 plus 0, is that less than or equal to 9? Yes. So I'm going to go ahead and shade everything inside the circle. So far I have this little region, looks like a little pupil, a little eye. That's my solution so far. But I have one more line, which I will do in red. So my last equation that I'm going to graph is 2x plus y is less than 1. So if I want to get y by itself, I'm just going to subtract that 2x over. And then this one is going to be a dashed line, so we got to be careful when we're drawing this one. At 1, I got a slope of -2. And then I've got a dashed line. So if I test a point, can I test 0, 0? Yeah, it's not on the line, right? So if I test 0, 0, if I plug in 0, I get 0 plus 0. Is that less than 1? Yes, so I'm going to shade on the side where 0, 0 is. So everything below that line over here is part of my solution for that red graph there. Okay, so then your final region, your area, that is your solution. And I would appreciate it if you at least kind of outline where that is. So this area here, yeah, is your solution, okay? So if you're shading all of your things, that's fine. Just make sure at the end that it's obvious to me which part is the actual solution for your graph, okay?